Why are some things electrolytes and other things non-electrolytes? So some things can conduct electricity while others can't. So for example, salt, when you dissolve it in water, it would conduct electricity and you could get a light bulb, for example, to work, conducts current. However, if you dissolve sugar, which is a non-electrolyte in water, you will not be able to conduct current. Why is that? Well, NaCl is an ionic compound, meaning it breaks into its ions when dissolved in water, right? It's made of a positive and a negative ion, so we get those charges. This molecule, sugar, or this is sucrose, when it gets dissolved in water, it does not break into positive and negative ions. There is no positive or negative part of a sugar molecule. It's a covalent compound. So covalent compounds made of all nonmetals, right, won't conduct because it still stays this big molecule when it is in solution. So I want to show you the simulation. Okay, so we're going to put some salt in this water. These are salt molecules. They've got positive and negative ions, and you'll see they break apart into positive and negative ions. So whenever they are dissolved in solution. So this is what it looks like when an ionic compound gets dissolved in solution. Now, if I remove that and I do sucrose instead, these big sucrose molecules, now the molecules will break into separate molecules, but this does not have a charge. Okay, this is a sucrose molecule at C12H22O11, and it stays as C12H22O11 whenever it is in solution. This would not be able to conduct electricity. All right, so if you go on a bigger scale, put salt in there, this will light up the light bulb, you can see because of the little things here. And then if you remove the salt, it turns off. And if I put in sugar, it will not light up the light bulb. And that is really the difference between an electrolyte and a non-electrolyte. Now, I've mentioned then electrolytes and non-electrolytes. However, there are what are called strong electrolytes and then weak electrolytes. Okay. So the difference is strong electrolytes are things like NaCl that completely ionize or completely dissociate, completely turn into their ions when they are in solution. So when they are dissolved. So this is really any type of, I'm going to look at number 3 here, soluble ionic compounds. Okay, I'll talk about which ones are soluble here in a minute. But an example would be potassium chloride, KCl. KCl, whenever you put it into water, breaks into K plus and Cl minus completely. So that's going to be for soluble ionic compounds. There are 2 other types of substances besides soluble ionic compounds that are also strong electrolytes. Okay, so keep in mind the ionic compounds are strong electrolytes, but so are strong acids and strong bases. So we will do a whole unit on strong acids and strong bases, and we'll talk about those in 162. But how do you determine if something is a strong acid or a strong base? Well, there's really only a few, and yes, you should memorize these. I won't have you memorize things a lot, but you should memorize these 6 strong acids. Okay, my mnemonic to remember them, it's not great. If you come up with another one, let me know, but it's the word bins. And then there are 2 chlorine ones. So B stands for HBr, or hydrobromic acid. I stands for HI, or hydroiodic acid. N stands for nitric, HNO3. And S stands for sulfuric, H2SO4. Then the chloride ones are HCl, that's hydrochloric acid, and HClO4, which is also a strong acid. So these are the 6 strong acids. They are the only acids that 100% ionize in solution. So what that means is I've got a nitric acid up here. Okay, this is nitric acid, HNO3. This is the H, this is the N, and these are my 3 oxygens. When this goes into water, it completely breaks into H plus is the one ion, and your nitrate ion is the other ion. So it does break completely into ions, which is why it is a strong electrolyte. So those 6 are the only acids that are strong electrolytes. There are also strong bases. Things that are bases are a group 1 or a group 2 metal. So when you're looking at the periodic table, the first column and the second column, those metals with a hydroxide or OH minus on it. So the one you are probably most familiar with, and we will certainly be using in the lab, is sodium hydroxide. That is Na with an OH on it. Okay? And OH minus is a polyatomic ion. So when you put this in water, you get Na plus and OH minus, 2 ions that completely break apart. So strong acids, which are just these 6, strong bases, which are group 1 or group 2 with the hydroxide, and ionic compounds are all strong electrolytes. Okay, so most of the time, You're going to see acids, bases, and ionic compounds, and you'd be like, strong electrolyte. Now, what is a weak electrolyte? Okay, a weak electrolyte are things that only partially ionize. So that means like only 1 to 2%. So instead of, for example, KCl breaking completely into K plus and Cl minus, some things, most of them stay together and only 1 to 2% of them actually break apart. These can conduct electricity, but they're very weak because they don't have as many ions. These are special cases. Okay, the only times you have weak electrolytes are for weak acids and weak bases. Now, how do you identify these? Well, an acid is something that starts with a hydrogen, okay, and then it's got usually some type of polyatomic ion or an anion after it. So anything that starts with an H, you can assume is an acid. H2O can act like an acid or a base, it's just water. But if it starts with an H, it's probably an acid. If it is not one of these 6, then it's a weak acid. Okay, so anything that starts with an H but is not bins or the chlorines is going to be a weak acid. Okay? So like coffee has weak acids in it. Citric acid is a weak acid. Malic acid, vinegar, lactic acid. These are all things that you've probably heard of before. These are weak acids. They can conduct a little bit of electricity because, for example, vinegar, this is vinegar, it is acetic acid, HC2H3O2. When it gets dissolved in water, it mostly stays together, but you get some H pluses and then acetate ions, C2H3O2 minuses. So it can conduct a little bit of electricity. So anything that's an acid that is not one of the strong 6. Same thing with bases. Anything that is a weak base that is something that's basic that is not a group 1 or group 2 metal with a hydroxide. Now, these are a little bit harder to recognize, so I won't do this to you very often. Really, most weak bases have some type of nitrogen or an NH in the compound somewhere. This is ammonia, for example. That's that like yellow cleaner if you've ever used it. NH3 is a weak base. So anytime you're going to see like a nitrogen type compound, if it's got nitrogen and hydrogen, probably a weak base. Okay, hydroxides are going to be strong. Things with nitrogen are going to be weak. Baking soda is a weak base. Soap is a weak base. This isn't my example that I was talking about a moment ago. Anything that's weak actually mostly stays together. This is acetic acid or vinegar. And we use this double arrow, like one half going forward and half going back to say, well, some of it stays like this, but some of it breaks into H plus and C2H3O2 minus. So we get a little bit of both in there. So it is a weak conductor or a weak electrolyte. Okay, so you can assume ionic compounds and strong acids and bases are strong electrolytes. Weak electrolytes are only weak acids, so if they start with an H and it's not one of the 6, or weak bases, usually something that's got a nitrogen in it, those are going to be weak electrolytes. Okay, and then the non-electrolytes are the things that don't dissociate at all. So they would be things that are not ionic and things that are not acids or bases, which really just leaves covalent molecules, things that are completely non-metals, but not acids, right? If it starts with an H, it's probably a weak or a strong electrolyte because it's an acid. All right, so things like this would be sugar or sucrose. This is our example before. Things that have carbon, hydrogen, and oxygen. These are usually organic molecules. This is kind of a generic formula. If it's got a carbon with N, can be any number, like C6, then it's going to have H2O times 6. So it'd be C6H12O6. That sounds familiar, right? Glucose. Glucose does not break into ions. Okay, so anytime you're seeing things with CH and O, formulas that looks like this, these are alcohols. They can dissolve, but they don't dissociate. You don't get any ions, all right? So our 3 categories are strong, which are ionic things, and strong acids and bases. I'm going to go down here, weak, which is covalent things, or sorry, non-electrolytes, which are covalent things, and then weak electrolytes in the middle are weak acids or bases. All right, so I would like you to try example number 1, label each of those substances as acidic, basic, or neutral, and then if they are strong, weak, or non-electrolytes. So remember, acids are going to be things that start with an H. Bases are going to have an OH minus at the end, or they might have a nitrogen in there with hydrogens. And then you can tell me if they're strong, weak, or non-electrolyte. So pause it and give it a try. Okay, these are our answers. So HF, I noticed right away this starts with an H. So this is an acid. Okay, so I would write acid here, or you can write weak acid. HF is not one of the 6 strong ones you need to know, so it's got to be a weak acid, which means it is a weak electrolyte. Okay, MgCl2, well, that's not an acid and it's not a base, and it is ionic because it's a metal and a non-metal. So if it's ionic, that means it's not an acid or a base, but it would be a strong electrolyte because it is a soluble ionic compound. This one here looks like a bunch of carbons and hydrogens and oxygens to me. It doesn't start with a hydrogen, so it's not an acid. And yes, it does have an OH here, but this is covalent molecule. So this is not a base. This is an alcohol, actually, that we talked about just right up here. But a bunch of carbons, hydrogens, and oxygens is going to be covalent. It is a non-electrolyte. Okay, it's only a base if it is group 1 or group 2 metals with OH minus. Okay, this one starts with an H, got to be an acid. This is one of the strong acids that we need to know. So it's going to be a strong electrolyte. Strong is strong. Like strong acid is strong electrolyte. Weak acid is weak electrolyte. They go together. Okay, this one here is carbons and hydrogens, but notice this little nitrogen here. That means it's going to be a weak base. Okay, so if it's a weak base, it is a weak electrolyte. And this is KOH. Okay, this would be a group 1 metal with a hydroxide, which means it's a strong base, so it is a strong electrolyte. Okay, if you want more practice with this, check out the active.